Welcome viewers. In this video we'll see the implementation of Boolean function using the demultiplexer. Example 2. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Implementation of Boolean function using the demultiplexer. Here two functions are given, f1 and f2. Three variables. The input is three variables a, b, c. That is given as sum of min term. f1, the function f1 having the min term 0, 3, 7. Only these three min terms are given for function f1. Similarly, function f2 need a sum of min term 1, 2 and 5. Right. These two functions we need to implement with the demultiplexer. We know that demultiplexer is nothing but one input with 2 to the power n outputs and n selection lines. So this is the basic structure of the demultiplexer, having only one input that is converted into 2 to the power n outputs. That is done by the selection line. The selection line convert one input into 2 to the power n outputs. Right. Here n is 3. There are three variables available. So 1 is to 2 to the power 3. That is 1 is to 8 multiplexer we need. Similarly, we need 3 selection lines. Right. So to implement this function f1 and f2 we need 1 is to 8 multiplexer and 3 with 3 selection lines are needed. What is this 3 selection line? This 3 selection line is nothing but ABC. 3 selection lines are ABC. What is the one input? One input is 1, logic 1. Right. So we got 8 different outputs will be available. For example, 8, 2 to the power 3, 3 variable means 8 combinations, 0, 0, 0, 0, 0, 1 like that. In that 8 combination, f1 require only 0, 3, 7. This is sum of min term. So 0, 3, 7 should be connected in one OR gate, so that this OR gate will add these 3 min terms. Similarly, here we need one more OR gate. We need to connect 1, 2 and 5. Right. So now we'll see the logic diagram. So we have the logical expression. Based on that, we decided 1 is to 8 multiplexer is needed with 3 selection line. 3 selection line is ABC. Input is logical 1. 8 different outputs available. In that we need to connect these corresponding inputs. Right. Now we'll go to the logical diagram. So this is the 1 is to 8 multiplexer Dmax. 1 is to 8 Dmax. The D is given as 1. The D is given as the 1. Logical 1. These are all 3 selection lines. Based on the value of the selection line, the output will be produced. For example, 0, 0, 0. A, B, C, 0, 0, 0 means Y0 will be available. Y0 will produce the output. This 1 will be available in Y0. All other terms will be 0. If it is ABC is 0, 0, 1, then Y1 will be produce the output. Other terms are 0. Similarly, 0, 1, 0 means Y2 will be produce the output. 0, 1, 1. Y3 will produce the output. 1, 0, 0. Y4 will produce the output. 1, 0, 1. Y5 will produce the output. 1, 1, 0. Y6. 1, 1, 1 means Y7. So these 3 selection line will decide which output will be higher and which are the other outputs are lower. 0, 0 means only Y0 will be higher, 1. All other terms will be 0. Right. Now we got the 8 different outputs. In that function 1, what we need only 0, 3, 7. Right. So 0 is available. So this is sum of min term. So we are using OR gate, one OR gate. So here we need to add 0, 3, 7. So 0 is connected and 3 is connected. Similarly, 7 is connected. 0, 3, 7s are connected. So that these 3 will be added together, sum of min term. We got the function f1. Similarly, function f2, what we need? 1, 2, 5. So we connected 1. 1 is connected. Then 2 is connected. Then 5 is connected. So these 3 inputs are connected. So it will give the sum of min term 1 to 5 function f2. Right. So we got the output by using this 1 is to D8 multiplexer, demultiplexer. We got the logical function f1 and F2, right? So in this video we discuss how to implement demultiplexer for a logical function. Here the description is available. With D in, input is 1. Demultiplexer gives min terms at the output. Min terms means 0, 1, 2 up to 7. So by logically ORing means sum of min term. By using OR gate, the required min terms we can implement. Required min term means for function we need 0, 3, 7. For function 2 we need 1, 2, 5. Right? That is 1, 2, 5. The required min terms are implemented, so that we can get the Boolean function F1 and F2. So here we discuss how to implement the demultiplexer for a given Boolean function. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.